graphing linear functions. So this says graph the functions and give the domain and range. So here's my function. And if I want to graph it using the X-Intercept and Y-Intercept method, I just go let y equals 0, let x equals 0. So I copy down my function. And here, when I say y equals 0, it's kind of the same thing as saying f of x equals 0. So if you look, there's no y in this function. So you go, well, where should I put the 0? Well, y of y is really the same as f of x. It's just another name. So I'm going to put the 0 where the f of x is. And then I'm just going to solve for x. And I get x equals 3. So I say if y is 0, I wrote this backwards here. If y is 0, then x is 3. Let me put a star so I can fix that. Okay. Now, if x is 0, so I put a 0 into the function. Wherever there's an x, I'm going to put a 0. And my function is equal to 6. So if x is 0, y is 6. So then I can plot these 2 points, join them up, and I've graphed my point. However, if I have something like this where it's just equal to one number, it's a little confusing. So what I love to use is I use a table of values. So I have x and y, and remember y is the same as f of x. They're kind of the same thing. So this says f of x is always negative 3. So I put in all negative 3's here because it's always negative 3. And then I can pick any number I want to go into the x to make my points. So here's my first point, second point, and then I just start graphing those points and I realize, oh, it's a horizontal line. Okay. Oh, I forgot about domain and range. So let's do the domain and range here. So domain is the x values. Where does this graph exist on the x-axis? Well, because it goes all the way this way and all the way this way, I'm going to use all the points, every number on the x-axis. So my domain is from negative infinity to infinity. But my range, my y values, are only one number. It's always equal to 3. So my range is very small. It's only one number. But up here, because it's just a normal line, not a special one that's like horizontal, if I keep, let's do the domain first, x. If I keep this arrow going and make the line keep going, eventually I'm going to use all the x values on the x-axis. So this is really going towards positive infinity on the x-axis. And because this keeps going up, I'm going to eventually use all the numbers on the negative side, and I'm going to hit negative infinity. So whenever I have a straight line, my domain is always negative infinity to infinity. My range, let's check, that's the y values. Where does the graph exist on the y-axis? Well, because this keeps going up and up, it's going towards positive infinity. It's going to go up forever. And it's going to go down forever. So it's going to go towards negative infinity. So the domain and range are both negative infinity to infinity. Let's look at the last one. So here, it's just equal to negative 3. So it gets kind of confusing to remember when it's a constant term, is it a horizontal line or a vertical line? So it says x is always 3, negative 3. So I'm going to put lots of negative 3's at x. And then y, I'm just going to put random numbers. Doesn't matter. And then I put them together to make a point. And I graph the point. And then I go, oh, when I start graphing them, I'll notice that it's a vertical line. Okay? Now here it says it's not a function. Well, how do I know? If I do my vertical line test, it's touching here at many places. So that's more than one place. So that means, no, it's not a function. Here it's a function because it only touches one place when I move my horizontal or my vertical line, do my vertical line test. Okay? So here, let's look at the range, y. It's going to go up forever and ever, towards positive infinity. It's going to go down, down, down forever towards negative infinity. So that's my range, negative infinity to infinity. But x is only one number. X is only ever negative 3. So my domain is negative 3. Okay. So let's do a couple examples. So I want to graph it. So I'm just going to do my X-intercept and Y-intercept. So let x equals 0. Let y equals 0. I copy out my function. I copy out my function. Wherever the x is, I'm going to put a 0. I'm going to put brackets because you need brackets. So now the x was here, so I'm going to put a 0. The x was here, so I'm going to put a 0. So f of 0 equals 0 plus 2. F of 0 equals 2. That's my answer. But what does that mean? We want points. So if x is 0, remember f usually stands for like y. So if you get confused, you don't know where this number goes, look up. X is 0, so this one must be 2. So I get my point, 0, 2. That's my first point. Let y equals 0. Well, there is no y. Really, that's the same as f of x equals 0. So we're going to put a 0 where the f of x is. And then equals 3x plus 2. Now we have to solve for x. It's like a mizan or a scale. So you're going to get rid of the 2. And I'm left with negative 2 equals 3x. I'm going to get rid of my 3. Same over same as 1. So that's really x equals negative 2 over 3, which is x equals negative 6.67. Oops, I put the point first. Negative 0.67. So it's almost negative 1. So this says x is almost negative 1 if y is 0. So let's plot this point. Almost negative 1 and 0. So there's my line. Any line that's straight, a straight line, as long as it's not horizontal, as long as it's not vertical, the domain and range are equal to negative infinity to infinity. Because this goes on forever and ever and ever and ever. You're going to use all your x's, all your positive x's, and this is going to go on forever and ever and ever, and you're going to use all your negative x's. Okay, same for the y's. So whenever you have a straight line that's not horizontal or vertical, the domain and range is this. Let's look at the next one. Graph the function and give the domain and range. So let x equals 0, let y equals 0, which is the same as f of x equals 0. Those are sort of the same thing. So we copy out the function. Now wherever the x is, we're going to put 0. We got to put a bracket. 0 goes where the x is. Okay, but we need a point. So this is x equals 0, so you put the 0 here, and this is the y. Oops, not a y, you want a 2. Silly me. So 0, 2, oh, it's the same. Okay, so now, if f of x is equal to 0, I'm going to put it here. That goes here. And now I have to solve for x. So get rid of my 2. Get rid of my 3, negative 3, be careful. Has to be exactly same over same, don't forget your negative. So x is equal to 0.67. If I put that in my calculator. So now I need the point. If y is 0, x is 0.67, takriban, approximately. So now it's positive 67. So now it goes that way. Is it a straight line? Yes. Is it horizontal? No. Is it vertical? No. So you know the domain and range are equal to negative infinity, infinity. Okay, let's look at the next one. F of x equals 2. Well, that's kind of the same thing as y equals 2 because f of x and y are kind of the same thing. So we usually do an x and y for our table of values, but really it's f of x now. So now it says f of x is always 2. It says f of x is always 2. It doesn't matter what your x is, y is always 2. So I'm going to put in numbers here. Let's do 4. Let's do 2, 0, negative 2. Now we're going to make these into coordinates or points. Now I'm going to graph them. 4, 2, 2, 2, 0, 2. Oh, I can see it's a horizontal line. There. So I just graph enough of these points so I can see if it's horizontal or vertical. So now, if I do my domain, this is going all the way towards infinity. Domain is about my x. And this is going all the way towards negative infinity. So my domain is negative infinity to infinity. My range is y. Well, this graph only exists when y equals 2. So my range is just a set of one number, 2. It only exists at 2.